Hey students, in this video I'm going through the answer key for the Chapter 7B, review number 1. So this is Chapter 7B, review number 1. Be sure you've completed this on your own before you watch this video. You may correct your work as you watch the video, and at the end, of course, let me know if you have any questions. Remember, this looks identical to your test. Your test is just going to have different numbers on each of the figures. So starting with number 1, find the number of faces, edges, and vertices of the solid. Faces are those flat surfaces. So first I'm going to count the top here. And remember, there has to be one on the bottom because this is fully enclosed. So top and bottom makes 2. I also have this one here at the front and another one at the back because again, it's fully enclosed. So that makes 3, 4. And finally, these make 5 and 6. There are 6 faces in all, 6 flat surfaces. Next, the number of edges. Edges are the line segments. That's where those flat surfaces connect. So each of those lines is an edge. So I'm going to count the ones going around the top first. I see 1, 2, 3, 4 going around the top. And then 5, 6, 7, 8 going around the bottom. Those dotted lines do count. And then the ones going up and down, 9, 10, 11, 12 in all. And then finally, my vertices. My vertices, those are the points or the little corners. They actually already have these dots on them for us. So there's 1, 2, 3, 4 around the top, 5, 6, 7, 8 around the bottom, 8 vertices. Next, on all of these, we're going to find surface area of the solid. Remember, surface area is when you find the area of all of the faces and add them together. Be sure to label each with units squared. So let's start with this one. It's a rectangular prism. We have just a bunch of rectangles. On this one, the front and back will have the same area, the top and bottom will have the same area, and the left and right sides will both have the same area, so that can help us as we go. So I'm just going to write T for top. The top, that is this one here. I'm going to color it in pink. This one has a length of 8 because even though we don't know how long this is, across we can see that it's 8, and a width of 10. Again, even though it's not labeled, look across and see that it's 10. So it's area, length times width, 8 times 10. We get 80 for the top. The bottom will be the same. Next, I'm going to do the sides. Again, the sides will be the same. I color this one in blue. Its length and width are 10 and 3.5. So for the area of the side, 10 times 3.5, we get 35. Again, that's for both sides. And then finally, we have the front and the back. I am going to color these ones in like a lighter blue. This one has a length of 8 and its width, even though it's not labeled, we can look across and see that it's 3.5. So for the front, 8 times 3.5, that makes 28. And again, the back will be the same, 28. So I have all my areas, 80, 80, top and bottom, 35, 35, side and side, 28, 28, front, back. Add them all together. If you use your calculator for that, you get 286. Be sure to label it with units squared, in this case, feet squared. Question 3, this one is a triangular pyramid. So it has one triangle base. There's just one base. Across from that, just a single point. So on pyramids, there are triangles around the sides. Now this one has 3 triangles going around the sides. Since the base has 3 sides, there's a triangle coming off of each. So I'm going to write side, side, side. Those 3 sides are going to have the same area. Those sides, the ones going up and down, each have a base of 8 and a height of 14. So I'm going to do base times height, 8 times 14. Remember to divide by 2. That's going to give me 56. So the area of each of the side triangles, the ones that are going like up and down, those are each 56. Now we also need to find the area of the bottom. The bottom in this case is a triangle. Its base is 8. Its height is 6.9 because its height is laying across the bottom there. So base times height, 8 times 6.9 divided by 2, we get 38.7 for the bottom. So the 3 triangle sides have the same area, but the bottom triangle is different. And then we'll go ahead and add those all up in our calculator to get 206.7. Remember to label with units, in this case inches, squared. Next, we're going to move on to 4. This is a square pyramid. It's still a pyramid because it has one base, but it's a square pyramid because the bottom is a square. Since the bottom is a square and a square has 4 sides, that means there's 4 side triangles for this one. And they, again, like the other pyramid, they're all going to be the same. We just happen to have 4 of them. So the base of each of those triangles is 6, and the height of each is 11.4. So base times height, 6 times 11.4, divided by 2, we get an area of 34.2. And again, that's the same for all 4 of those side triangles. Now we also have the bottom. The bottom is a square, and in a square, all 4 sides are the same. So if this side is 6, so is this. Length times width, 6 times 6, we get 36 for the area of the bottom. Now let's go ahead and add them all up in our calculator. We get 172.8. Remember to label it with units, in this case yards, squared. Question 5, this is a triangular prism. So this one, I'm going to actually do this one a bit differently. Instead of calling the different faces, top, bottom, side, anything like that, I am going to draw the 2 triangles that are a part of this, the top and the bottom, and then there are 3 rectangles. The reason I'm doing it like this is because in a triangular prism, these 3 rectangles could be completely different. And sometimes when we label them as like side and side, we think they're the same, but they could be different. The only 2 that are for sure the same are the 2 triangles. So let's start with the triangles. Remember, a right angle is always right because it shows the base and height. These 2 sides touch the right angle. This one is 4 because it's across from 4. This is also 4 because it's across from 4. So the base and the height are 4 each. 4 times 4 divided by 2, get 8. So the area of both triangles is 8. We're not using 5.7 because it's not the base or the height of the triangle. 4 and 4 are the base and height. So those are the only 2 that are for sure the same. Now let's do the 3 rectangles. Some of them could be the same, but not always. First, this one right here that I'm going to color in pink. This one has a length and width of 3 and 4. 3 times 4 is an area of 12. Now this one on the left that I'm coloring in blue actually is the same, but remember that's not always going to happen. It has a length of 4. This isn't labeled, but across we can see it's 3. So 3 times 4 again. And then finally, that one at the back, we kind of trace it, we can see that its length is 5.7 and its width is 3. When I multiply those, I get 17.1. Excuse me. And now I'm going to go ahead and add them all together, and I get 57.1. Label it with units, millimeters squared. All right, now we're going to the back side. 6 and 7, we're going to find the volume of the rectangular prism. Remember, volume equals length times width times height. So for number 6, my length is 1, my width is 1 1/3, my height is 1/2. But you can label yours differently. Since we're multiplying, the order doesn't matter. So volume equals length, 1 times width, 1 1/3, times height, 1/2. Now I have a whole number and a mixed number, and I would like to change these to be improper fractions. So first, the number 1, I can write that as 1 over 1. For 1 1/3, I need to multiply. 1 times 3 is 3. Add 3 plus 1 is 4. Denominator stays the same, so it changes to 4/3, and then 1/2 we're going to leave alone. And now we can go ahead and look for cross canceling. So I'm just going to cover the fractions up one at a time. If I cover up the first one, I can see that with 4 and 2, there is cross canceling. I can divide both by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. There's no cross canceling with 1 and 3. Next, if I cover up that middle fraction, there's no cross canceling with 1 and 1 either direction. And finally, there is no cross canceling with 1 and 3 or 2 and 1. So I'm done cross canceling. I can multiply straight across the top, straight across the bottom. 1 times 2 is 2, times 1 is still 2. 1 times 3 is 3, times 1 is still 3. So we get 2/3, and remember to label it with units, in this case feet, cubed. It's volume, so now we need to label it as cubed. And question 7, again, let's label length, width, and height. I'm going to say length is 5/8, width is 3/4, height is 2, but you can label yours differently. So volume equals length, 5/8, times width, 3/4, times height, 2. So we are going to want to change this whole number into an improper fraction. So 5/8 can get left alone, same with 3/4, but I can change 2 to be 2 over 1. And again, we're going to look for cross canceling. We'll cover the fractions up one at a time. If I cover up the first one, there's no cross canceling with 3 and 1, but I can divide 2 and 4 by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. If I cover up the middle fraction, nothing with 5 and 1, nothing with 1 and 8. And finally, nothing with 5 and 2, nothing with 3 and 8. So we're done cross-canceling. We can multiply straight across the top and the bottom. 5 times 3 is 15, times 1 is still 15. 8 times 2 is 16, times 1 is still 16. So we get 15 sixteenths, remember to label with units, in this case meters, cubed. It's volume, so we need to label with units cubed.